Hello and welcome. Today we are going to see the practical number 3, of course, elements of machine design. In last two practicals, we have seen regarding the design procedure as well as the introduction to different codes. Today in practical number 3, we will discuss about the design of springs. Already we have completed the theory portion of this design of springs. In this session we will just revise how the design of spring is calculated and what are the stresses that are considered while designing a particular spring. So start with the practical number 3. The practical outcome of this practical is to design of springs. Means after completion of this practical, the student should be able to design a spring. This is actually practical number 12 in our index. So as continuation, I am saying that it is the practical number 3. So practical outcome is to design a particular spring. Means after completion of this practical, the student should able to understand the different functions of springs, what are the different ends of springs, how the springs are designed, what are the stresses that are considered while designing a particular spring. So before actually going into the design of spring, it is necessary to understand some basic concepts regarding the spring. So a mechanical spring is a resilient member which is capable of providing a large static deformation. Means when we apply a load on a particular spring, it undergoes deformation, and it is a elastic deformation, not a plastic deformation. Means when we apply a load on spring, that spring undergoes a deformation through some length, and after removal of that load, again that spring comes to its original position. That's why we are saying that it is a elastic deformation. So it is a resilient member which is capable of a elastic deformation. It is an elastic body which distorts when loaded and recovers its original shape when the load is removed. As we have discussed, as it is an elastic body, when we apply a load on spring, it undergoes deformation, it undergoes a change in length, change in shape, and when we remove that load, it again regains its original shape and original length. So if we see through the pictorial representation, this is a spring. K is the stiffness of that spring. Now K is the spring material property. K varies from material to material, which is given in Newton per mm, and P is the load applied on this spring. Now this is the original length of the spring. When we apply a load of P Newton on this spring undergoes a deformation of delta. So we get equation for K, that is stiffness is equal to load per unit deflection. Due to the load P, the spring undergoes a deflection of delta. So the value of applied force we get P is equal to K into delta, where K is the spring constant. It is also known as the stiffness of that spring. So here we can understand the concept of stiffness. The stiffness is defined as the load per unit deflection of the spring due to the applied load, and its unit is Newton per mm. Newton means force per mm. Mm is the deformation, that is change in length of the spring. Now what are the different functions of the spring? As it is an inelastic body, it exerts force Example, springs in safety valves and spring washer. As the spring is an elastic member, it exerts some force on a certain mechanism. It provides flexibility, means it can change its dimensions with the application of load so that it can provide a flexibility to the mechanism for which it is used. And most important part, it stores and absorbs the energy. Now this property of the spring is used in the mechanical engineering, that springs absorbs the energy or it stores the energy. When we apply a force of P Newton on the springs, it stores that energy due to that force. So this property is used in the most of the applications, say automobile suspension and clock springs. Now let's see the classification of springs, how the springs are classified. Now in broadly we can classify as a coil spring or wire spring and flat springs. Now under coil spring the subtypes are helical tension spring, helical compression spring and torsion spring. In case of flat springs, leaf springs, spiral springs and bevel springs. Now helical tension spring, why it is known as the helical tension spring? Because it is in the tensile condition. When we apply a load on it, it gets in tensile position, and when we remove load, it again comes to its original position. So it is used in an application where we require a tensile force to be applied. ज्या ठिकाणी ज्या applications मध्ये आपल्याला tensile force त्या स्प्रिंग वर एक्झर्ट होणार आहे, अशा ठिकाणी आपण ते स्प्रिंग्स वापरतो. त्याचे ॲप्लिकेशन्स काय आहेत टेन्साइल स्प्रिंगचे, हेलिकल टेन्शन स्प्रिंगचे? ड्रम ब्रेक्स, कार्बोरेटर्स, spring balance and electrical equipment. These applications are very important. How these helical tension springs are used in these applications. Now this is the helical tension spring. Now if we take the look on this is a carburetor. How this springs is used in the carburetor, how this is spring used in the suspension. Now this is a drum brake. How the helical tension spring is used in the drum brake. Now this is the railway buffers. How the springs are used in the railway buffers. Now we can use the helical compression spring in the railway buffers. This is the helical compression spring. Now initial condition it is in the tensile condition, but when we apply a force on it, it undergoes a compression. That's why it is known as the compression spring. Means it sustains a compressive force. Helical tension spring sustains a tensile force. Helical compression spring sustains an compressive force. Its applications are car springs, railway buffers and cam and followers for the helical compression springs. Next is the torsion spring. Now it is a round or a square wire. It is also a round or a square wire. It is also a round or a square wire. Now the best example of torsion spring is the hinges, door hinges and garage doors, where we are lever return applications. For the pedal applications where we are using the torsion springs. These are the torsion springs. How this torsion springs works. Now this is the pedal or lever mechanism. When we are putting the pedal on it, when we apply force, it comes in the round condition. Again we remove the force, it comes into original position. These are the loaded to close. Now open and close application in the hinges. How these torsion springs are used. Now as it is having a wire in a round or square form, that's why it is known as the wire or coil springs. Now flat springs, leaf spring, the common spring that we are using is the leaf spring. It is a cantilever or elliptical type. We have already seen the theory part of the leaf spring. What is the construction of the leaf spring? How many plates are there? What is meant by eye? What is meant by counterbolt? What is meant by rebound clip? What is meant by the master leaves? Applications of the leaf spring is the suspension systems. Many times we have seen the suspension system. Now these are the leaf springs. These are the leaf springs which are used in the suspension systems. These are the leaf springs. How the leaves undergo a force, how it absorbs the shocks, how it absorbs the load. It flattens and again it comes to its original position. So these are the master leaf, the longest leaf, and it is made up of the different leaf, and rebound clip is attached to it so that it can form a bundle. So this is the how it spring actually functions in the certain applications. Now these are the for the suspension systems, how these leaf springs perform its task in the suspension. Spiral spring. It is a wound form or clock type power spring. If we take the example of a clock, it will wound a certain spring and it will store the energy and it will perform the task of the wristwatch or all watch where springs are used. These are the spiral springs, how it stores the energy. When we move clockwise or anti-clockwise, it will store energy, and after releasing force again it will come to its original position and performs the action of a particular motion. So this is regarding the different types of the springs that we are using in the applications. Now design of helical springs. Our discussion or our aim of this practical is to understand how the springs are designed. In that, how the helical spring is designed. So it is a process of determining the dimensions of the springs. As already we know that the design means determining the dimensions of a particular element. In the same way, when we are going for the design of a helical spring, that means we have to determine the dimensions of the helical spring. And already we have seen what are the different dimensions of the helical spring: free length, solid length, diameter of wire, coil diameter, stiffness of the spring, load which is applied on the spring, energy stored by the spring. These are the different dimensions that we have to determine while designing a spring. Now what are the different considerations when we are going for designing a particular spring? What are the different considerations that we need to consider while designing a particular spring? First is the selection of appropriate spring material. Through different spring materials, we have to select a particular spring material for that required application. Second is space into which the spring must fit. Where we are going to use that spring, for which application we are going to use that spring, where we are going to fit that spring. Third is the values of working forces and deflection. We need to calculate the different loads acting on the spring. What is the maximum load acting on the spring? What is the nature of the load acting on the spring? And accuracy and reliability needed. प्रत्येक ॲप्लिकेशन मध्ये आपल्याला रिलायबिलिटी ही महत्त्वाची आहे, तसंच ॲक्युरसी ही महत्त्वाची आहे. तर या आस्पेक्ट मध्ये आपल्याला किती ॲक्युरसी हवी आहे, किती रिलायबिलिटी हवी आहे, त्यासाठी आपल्याला या दोन्ही गोष्टींचा स्टडी करणं महत्त्वाचं आहे. सगळ्यात महत्त्वाचं कन्सिडरेशन मटेरियल कोणतं असलं पाहिजे, त्याचं स्पेस कन्सिडरेशन काय आहे, आणि ते किती वर्किंग फोर्सेस किंवा जे लोड्स त्याच्यावर ॲप्लिकेशन अप्लाय होणार आहेत किंवा त्याचं डिफ्लेक्शन किती होणार आहे, या सगळ्या आपल्याला व्हॅल्यूज कॅल्क्युलेट करणं महत्त्वाचं आहे. नाउ द प्रायमरी कन्सिडरेशन in the design of the spring is that the induced stresses are below the permissible limits. हे खूप महत्त्वाचं आहे. The stresses that going to induce at the time of the actual working, जेव्हा ती स्प्रिंग आपण एखाद्या ॲप्लिकेशनसाठी यूज करणार आहे आणि जेव्हा ती स्प्रिंग ॲक्च्युली आपण यूज करत आहोत एखाद्या ॲप्लिकेशनमध्ये, त्यावेळेस त्याच्यावर एक्झर्ट होणारा फोर्स जो असतो, मग तो टेन्साईल असेल किंवा कॉम्प्रेसिव्ह असेल, तो जो फोर्स आहे त्या फोर्समुळं त्याच्यामध्ये जे स्ट्रेसेस इंड्यूस होणार आहेत स्प्रिंगमध्ये, ते स्ट्रेसेस हे परमिसिबल जे लिमिट आहे, समजा एखादं मटेरियल आपण जर यूज केलं, समजा कार्बन स्टील हे जर मटेरियल आपण यूज केलं स्प्रिंग मॅन्युफॅक्चरिंगसाठी, तर कार्बन स्टील याचं जे परमिसिबल स्ट्रेस लिमिट आहे की तो किती स्ट्रेस इंड्यूस करू शकतो किंवा किती स्ट्रेस रेजिस्ट करू शकतो, तर त्या लिमिटच्या आत जे वर्किंगमध्ये जे स्ट्रेसेस त्याच्यामध्ये इंड्यूस होणार आहेत, जेव्हा ते स्प्रिंग आपण वर्किंगमध्ये यूज करणार आहोत त्यावेळेस त्याच्यावर जे ॲक्ट होणार किंवा इंड्यूस होणारा जो स्ट्रेस आहे हा जो परमिसिबल जो स्ट्रेस आहे त्याच्यापेक्षा कमी असणं गरजेचं आहे. नाउ we have to design the spring by taking into two considerations. First is the load stress equation and second is the load deflection equation. Means what? लोड अप्लाय केल्यामुळं त्याच्यामध्ये किती स्ट्रेस आणि कोणता स्ट्रेस इंड्यूस झाला आणि लोड अप्लाय केल्यामुळं त्याच्यामध्ये किती डिफ्लेक्शन इंड्यूस झाला, या दोन्ही गोष्टींचा विचार करून आपल्याला स्प्रिंग ही डिझाईन करणं गरजेचं आहे. मीन्स वी हॅव टू कन्सिडर दिस बोथ फॅक्टर्स व्हाईल डिझायनिंग दी बोथ इक्वेशन्स व्हाईल डिझायनिंग दी पर्टिक्युलर spring. So start with the design of spring. What is the procedure for design of spring? The first step, select mean coil diameter. Mean coil diameter किती coil diameter चा आपल्याला स्प्रिंग हे डिझाईन करायचं आहे. त्याचं वायर डायमीटर काय असलं पाहिजे आणि त्याची नंबर ऑफ ऍक्टिव्ह टर्न्स, जे आपण ऍक्टिव्ह टर्न्स म्हणतो, जे ऍक्च्युली त्या डिफ्लेक्शनच्या प्रोसिजरमध्ये पार्टिसिपेट करतात, की लोड जेव्हा आपण अप्लाय करतो तेव्हा किती ऍक्टिव्ह टर्न्सवर तो लोड ॲब्झॉर्ब केला जातो, तो सस्टेन केला जातो, डिपेंडिंग अपॉन दी ॲप्लिकेशन अँड स्पेस लिमिटेशन्स. द सेकंड स्टेप काय आहे, सिलेक्ट सुटेबल स्प्रिंग मटेरियल. जे आपण पाठीमागे बघितलं की कोणतेही स्प्रिंग डिझाईन करण्याच्या आधी जो ॲप्लिकेशन आहे त्या ॲप्लिकेशनचा विचार करून वी हॅव टू डिसाइड अ पर्टिक्युलर स्प्रिंग मटेरियल. व्हॉट शुड बी द स्प्रिंग मटेरियल डिपेंडिंग अपॉन दी ॲप्लिकेशन, कन्सिडरिंग द लोड अँड एन्व्हायरमेंटल कंडिशन्स. आता स्प्रिंग मटेरियल कोणते आहेत, पॅटेंटेड अँड कूल्ड ड्राउन स्टील वायर्स, ऑइल हार्डन्ड अँड टेम्पर्ड स्प्रिंग स्टील वायर्स अँड ऑइल हार्डन्ड अँड टेम्पर्ड स्प्रिंग स्टील वायर्स, अलॉइड अँड अनअलॉइड. त्याचे ॲप्लिकेशन्स आहेत की ते कोणत्या पर्टिक्युलर ॲप्लिकेशनसाठी यूज केलं जातं. आता जर आपण पॅटेंटेड आणि कोल्ड ड्रॉन स्टील वायर्स अनअलॉइड त्याचा विचार केला आपण, तर दिस इज अ कोल्ड ड्रॉन चिपेस्ट स्प्रिंग स्टील नॉर्मली यूज्ड फॉर द लोअर स्ट्रेसेस अँड स्टॅटिक लोड्स. जर कमी लोड असेल किंवा त्यामध्ये स्ट्रेस इंडक्शन हे कमी होणार असेल तर त्या केसमध्ये आपण हे पॅटेंटेड अँड कूल्ड ड्रॉन स्टील वायर्स यूज करू शकतो. द मॉड्युलस ऑफ रिजिडिटी, म्हणजे मटेरियलचा जो मॉड्युलस ऑफ रिजिडिटी आहे तो किती आहे, 81370. Shear stress upon shear strain, that is the modulus of rigidity, the ratio of shear stress to the shear strain. Its value is 81370 Newton per mm square. जे ऑइल हार्डनर आहेत, आता हे पॅटेंटेड आणि कोल्ड ड्रॉन आहेत. जर ऑइल हार्डनर म्हणजे जर आपण हार्डनिंग प्रोसेसमध्ये जर आपण ऑइल क्वेंचिंग केला असेल, ऑइल हार्डनर अँड टेम्पर्ड स्प्रिंग स्टील्स अँड वॉल्व स्प्रिंग वायर्स, as the name suggests, these are used for the manufacturing of the valves. It is a cold drawn, quenched, oil quenched, tempered and general purpose spring steel. It is not suitable for the fatigue and sudden loads. ज्या ठिकाणी सडन लोड येणार आहेत, स्टॅटिक लोड असतात, डायनॅमिक लोड असतात, शॉक लोड असतात, इम्पॅक्ट लोडिंग असतं, सडन लोडिंग असतं, डिफरंट टाइप्स ऑफ द लोडिंग आहेत. तर ज्या ठिकाणी आपल्याला सडन लोडिंग येणार आहे अशा ठिकाणी आपण हे स्प्रिंग मटेरियल वापरू शकत नाही. So these are the some spring materials that we can use for the manufacturing of a spring. Stainless spring wires for normal corrosion resistance application. ज्या ठिकाणी स्प्रिंग मटेरियल हे एखाद्या ह्युमिड ॲटमॉस्फिअरला सब्जेक्ट होणार आहे, ज्या ठिकाणी पाण्यामध्ये स्प्रिंगला काम करायचं आहे, अशा ठिकाणी आपण हे स्टेनलेस स्टील स्प्रिंग वायर्स वापरू शकतो, जे आपल्याला करोजन रेजिस्टन्स प्रॉपर्टी देतात. आता पहिल्या स्टेपमध्ये आपण काय केलं, त्याचं मेन कॉईल डायमीटर सिलेक्ट केलं, त्याचं वायर डायमीटर सिलेक्ट केलं आणि त्याचे नंबर ऑफ ॲक्टिव्ह टर्न्स आपल्याला किती पाहिजे ते आपण सिलेक्ट केलं. नंतर काय केलं, स्प्रिंग मटेरियल कोणतं आहे ते आपण सिलेक्ट केलं. थर्ड स्टेपमध्ये काय, सिलेक्ट ॲप्रोप्रिएट स्प्रिंग इंडेक्स. स्प्रिंग इंडेक्स काय असतो, mean coil diameter to the wire diameter. It is the ratio of mean coil diameter to the wire diameter. जेव्हा आपण मेन कॉइल डायमीटर सिलेक्ट करणार आहोत, कॉइल डायमीटर सिलेक्ट करणार आहोत, या दोघांचा वापर करून then we can determine the spring index of that material. Now how we can choose? If it is an industrial applications, then we can go for the 8 to 10 spring index, and if it valves and clutches, then we can go for the spring index as a 5. Now depending upon for which application we are actually designing that spring, now depending upon that application we can go for the spring index. If it is an industrial application, then you can choose a spring index of 8 to 10. If it is valves and clutches, then you can choose the spring index of 5. The spring index should never be less than 3. Keep in mind, as an engineer, you should keep these things in mind, that while designing a spring, the spring index of that spring should not be less than 3. Means the ratio of mean coil diameter to the wire diameter should not be less than 3. That is the meaning of the spring index. That spring index should not be less than 3. Now after determining the spring index, the next step is calculate the resultant shear stress developed in spring wire and the deflection of the spring for the given load. As we know that we have to design a spring by taking into consideration two equations, that is load stress equation and load deflection equation. So by taking into account these both equations, that is the load stress equation and load deflection equation, we have to calculate the resultant shear stress which is developed in the spring wire as well as the deflection of the spring which is caused by the application of load. So these two values are most important before actually going into the design of spring. Now sometimes the wire diameter and mean coil diameter and the number of two turns is to be calculated with the help of these two values. Before actually selection of these diameters, if the selected values are not up to the mark, then by determining the stress which is induced in the spring, in the deflection of the spring, then by using these stresses we can find out the dimensions of wire diameter, mean coil diameter and number of active turns. Now while designing the spring on the basis of load stress equation, this one note is important, that calculated resultant shear stress must be less than the working stress. Now design stress is equal to 30% of SUT, that is the ultimate tensile strength of the spring material. Means calculated resultant stress should be 30% less than the ultimate values of the tensile strength of the spring material. That we have to use this equation, design stress. We need to use this equation for the designing of a material. How to calculate the shear stress? Design stress or working stress is equal to 0.3 times ultimate tensile strength of the spring material. That equation you have to use. Now these are the stress equations. We have to design a spring by taking into account load stress equation and load deflection equation. Now when wire of the helical spring is uncoiled, means when it is not in coil position and straightened, it will take the shape of bar of a diameter d, length will be pi d n. जर समजा तुम्ही एखादं स्प्रिंग हे अनकॉइल कंडिशन मध्ये असेल, म्हणजे त्याचं कॉइल जर फॉर्म झालं नसेल आणि जर तुम्ही कॉइल केलेली स्प्रिंग जर अनवाउंड केली, जर ती स्ट्रेट केली तर तो एक स्ट्रेट बार बनेल. लक्षात घ्या. जर आपण जेव्हा पण कॉइल स्प्रिंग करतो किंवा जर कॉइलिंग जेव्हा करतो स्प्रिंगचं, याचा अर्थ आपण स्ट्रेट बारला वाउंड करतोय आपण. आणि जेव्हा वाउंड केलेली स्प्रिंग आपण जेव्हा अनवाउंड करू तेव्हा आपल्याला एक स्ट्रेट बार दिसेल की ज्याचा डायमीटर हा डी आहे आणि ज्याची लेंथ काय असणार आहे, सर्कम्फरन्स इंटू नंबर ऑफ टर्न्स, दॅट इज पाय डी इंटू एन. द रिझल्टंट मॅक्सिमम स्ट्रेस in the wire may be calculated by tau 1 and tau 2. Now tau 1, this is the torsion equation, pi by 16 tau d cube. There is a torque is equal to pi by 16 tau d cube, and this is the direct shear, this is the torsional shear stress, and this is the direct shear stress. P by pi by 4 d square means force upon area, and this equation you get from torque is equal to pi by 16 tau d cube. This is the tau 1. This is the tau 1. That is the torsional shear stress, and this is the torque mt. Now combining these two equations and substituting torque is equal to force into radius. Force is the P and radius is the d by 2. Now d is the mean coil diameter. Mean coil diameter divided by 2. If we take common from this 8p, now pi by 4p. If we rearrange this equation, 4p upon pi d square. If we take 8pd upon pi d cube common, then we will get, now we have to put this mt is equal to p into d by 2. Put here torque is equal to force into radius. Radius is the mean coil diameter divided by 2. So this is the force, it is the torque, force into radius. We need to put this value of mt here, means torque. By putting this value you get 8pd upon pi d cube. Same here, after taking common 8pd upon pi d cube, we get 1 plus 0.5 divided by d. A shear stress correction factor, if we take into consideration the shear stress, then we have to use this Ks. We have seen the Wahl's correction factor. And if we are designing the spring by taking into consideration shear stress factor, then the shear stress factor is Ks. This whole bracket is the Ks. So our equation becomes maximum shear stress is equal to Ks into 8p upon pi d cube. In this case we have not considered the Wahl's correction factor. In this case we have only considered the shear stress factor. So we have used this equation Ks 8p upon pi d cube. This is the maximum shear stress which is induced in the spring, which we can calculate. Now when the bar is bent in the form of helical coil, the length of the inside fiber is less than the length of the outside fiber. The result is stress concentration at the inside fiber of the coil. Now equation 9.4. Now this equation what we have used for the calculation of maximum shear stress. हे जे आपण इक्वेशन कन्सिडर केलं होतं त्यामध्ये फक्त आपण shear stress हा एकच फॅक्टर कन्सिडर केला होता. याच्यामध्ये आपण स्ट्रेस कॉन्सन्ट्रेशन. Now equation 9.4 does not consider the effect of stress concentration due to curvature of the coil. म्हणजे जेव्हा आपण कॉइलिंग करणार आहे, जेव्हा आपण स्प्रिंग तयार करणार आहे, तेव्हा त्या ठिकाणी जो कर्वेचरचा इफेक्ट आहे जे या ठिकाणी सांगितलेला आहे की जेव्हा आपण त्याला हेलिकल फॉर्म मध्ये वाउंड करू, जेव्हा आपण स्प्रिंगला हेलिकल फॉर्म मध्ये वाउंड करू, कॉइल करू, त्यावेळेस द लेंथ ऑफ इनसाइड फायबर इज लेस दॅन द लेंथ ऑफ आउटसाइड फायबर. याला म्हणायचं कर्वेचर इफेक्ट. हे याच्यामुळे काय होतं की इट विल रिझल्ट इन द स्ट्रेस कॉन्सन्ट्रेशन ऍट द इनसाइड फायबर ऑफ द कॉइल. पण हे जे इक्वेशन आहे हे इक्वेशन हा इफेक्ट कन्सिडर करत नाही आहे. तो इक्वेशन जर आपल्याला कन्सिडर करायचा असेल तर जो आपल्याला वॉल्स फॅक्टर आहे तो आपल्याला यूज करावा लागतो. द इक्वेशन फॉर द रिझल्टंट मॅक्झिमम शेअर स्ट्रेस considering the effect of stress concentration due to curvature is derived by the M. Wahl's. आपण पाठीमागे Ks यूज केला होता म्हणजे स्ट्रेस कॉन्सन्ट्रेशन फॅक्टर घेतला होता. या ठिकाणी आपण हा Wahl's करेक्शन फॅक्टर घेतोय ज्याला आपण म्हणतो Wahl's करेक्शन फॅक्टर, ज्याची व्हॅल्यू दिली जाते K is equal to. So in this case we have only considered the shear stress concentration factor, but in this case we are considering the Wahl's correction. जेव्हा आपण कर्वेचर इफेक्ट कन्सिडर करतो तेव्हा आपल्याला वॉल्स करेक्शन फॅक्टर कन्सिडर करणं गरजेचं आहे डिझाईन करण्यासाठी. जेव्हा आपण कर्वेचर इफेक्ट निग्लेक्ट करतो त्यावेळेस आपल्याला शिअर स्ट्रेस फॅक्टर कन्सिडरेशन करणं गरजेचं आहे. पण प्रॅक्टिसमध्ये आपल्याला व्हाईल डिझायनिंग अ स्प्रिंग इन प्रॅक्टिकल ॲप्लिकेशन्स वी हॅव टू कन्सिडर दी कर्वेचर इफेक्ट. नाउ दीज आर द स्टाईल्स ऑफ एंड. जे एंड्स आहेत स्प्रिंगचे ते स्टाईल्स आहेत. हे जे एंड्स आहेत, एंड्स कसे आहेत स्प्रिंगचे, डिफरंट स्टाईल्स आहेत. Diagram shows the common method of forming the ends of the helical compression spring. The turns at the two ends do not affect the deflection calculated by the load deflection equation. Plane end and ground end, square end ahead, square end, ground end. Now, what students has to do? What is the students' activity? Design a closed coil helix spring used for an automobile suspension system. The students has to carry out any one of the activity in group of 4 to 5. First, observe the automobile chassis of any vehicle or mechanism of the test rig in any of the laboratories used for the practicals of the mechanical engineering. Identify at least 5 different springs used. Take the photograph of each showing their actual position. Write the specifications of the identified springs, that is C, maximum deflection, material, solid length, free length, हे सगळं आपण करायचं आहे. दुसरी ॲक्टिव्हिटी आहे ऑब्झर्व अँड राईट डिफरंट टाइप्स ऑफ द लिप स्प्रिंग्स, की वेगवेगळ्या लिप स्प्रिंग्स कोणत्या असतात. Also state the materials used for the manufacturing of the lip springs and write the design criteria for the lip spring. And third activity आहे identify the type of the spring used in the bicycle stand. Write the necessary specifications for the design of identified spring and design the same. So students has to carry out any one of the activity. So this is regarding the practical, that is the design of spring. Thank you.